Hi friends, we have a greater integer function here and we have a square root and a quadratic equation within the square root which is in the denominator. We have to find the domain of this function 1 by under root greatest integer function of x whole square minus again greatest integer function of x minus 6. Okay, so firstly we have to ensure that this whatever is there in the denominator can never be 0 and at the same time whatever there is there in this square root should always be greater than 0, should always be positive. Okay, one thing, the denominator cannot be 0 and what is there in the square root should always be positive. Okay, let us assume this greatest integer function of x. This let us replace this with some y, then it will become like y square minus y minus 6. It's a quadratic equation. First, let us solve that. Okay, so if you try to solve something like y square minus y minus 6, we can write it as y square minus 3y minus, sorry, 3y plus 2y minus 6, which is nothing but y into y minus 3 plus 2 into y minus 3. That means y is either 3 or y is minus 2. Okay, y plus 2 into y minus 3. Ideally, greater than this should be greater than 0. That's what we are looking for. Right. Now, when will this be greater than 0? So here we have minus 2 and here we have 3, right? Whenever y is greater than 3, this side, then this is also positive, this is also positive, so it will be greater than 0. And whenever y is less than minus 2, then both are negatives. Okay, so for example, if it is minus 4 plus 2 minus 2, and minus 4, minus 3, minus 7, both are negatives, then also it will be positive. So as long as y is less than minus 2 and or y is greater than 3, then this expression is positive. Okay, if it is lying in between, then that means one of them is negative, one of them is positive. So y minus 3 will be negative, y plus 2 is positive, so it doesn't work. Right, for example, if y is 0, this becomes minus 3 and this becomes 2, which will be negative. So it doesn't work that way. So y can be less than minus 2 or greater than 3. Okay, so what is y? Y is our greatest integer function of x, which is less than minus 2 or greater than minus 3. So greatest integer function of x is less than minus 2 means what? Greatest integer function is always integer. So greatest integer function of x is minus 3, minus 4, minus 5, etc. We cannot have minus 3.5, minus 4.5 and all because this is always an integer, right? Similarly, when it is greater than 3, what does it mean? It means either 4, 5, 6, 7, whatever. Like this. This is also integer. Now, greatest integer function of x is 4, 5, 6. What does that mean? X has to be greater than or equal to 4. X can be 4.1, 5.1, 4.9, whatever. Okay, x can be 4 also. Okay, then we can have these values 4, 5, 6 and all. X cannot be 3.9 because if x is 3.9, greatest integer function of x will be 3, which will not work for us. So x should be greater than or equal to 4. And similarly, when greatest integer function of x is minus 3, okay, it is 0, x is minus 3, it is minus 4 and all. Okay, so what does that mean? This is minus 2. X can be anywhere from here. Anywhere x can be less than minus 2. So for example, it is minus 2.5. Then it will be greatest integer function of x is minus 3, right? Which is lesser than x, right? If it is minus 2.5, what is the greatest integer that is lesser than minus 2.5? It is minus 3. So it has to be less than minus 2. If it is equal to minus 2, then again, greatest integer function of minus 2 is minus 2. Okay, so strictly it has to be lesser than minus 2. And in this case, it has to be greater than minus 4. So what is the domain? Minus infinity to minus 2. Please note the open bracket here. It is not closed bracket. It has to be strictly less. Union, it can be greater than or equal to 4. Okay. Please note the closed bracket here. This is important. Okay. So very simple problem. Hope you like this. Okay, so what is the correct answer? Minus infinity to minus 2 open bracket. Minus infinity to minus 2 open bracket. And 4 to infinity close bracket. Okay. This is the correct answer. Right, guys. Hope you like this. Thank you.